You've probably heard it by now. Functional programming is becoming a buzzword. More and more developers are talking about it, job posts are mentioning it, and modern frameworks are quietly adapting its concepts. But what actually is functional programming and why you should care? In this video, I will explain it in simple and practical way using real Java examples. My name is Matúš. I am senior software engineer with more than 8 years of experience in software development industry. So let's start with the definition of what is functional programming. Functional programming is a programming paradigm centered around writing code using functions as a primary building blocks. It emphasizes expressing logic throughout transformations and declarations rather than writing step-by-step instructions. It promotes clear and predictable flow of data, which makes code more reliable, maintainable, and easier to reason about. It's widely supported in modern languages such as Java and Python. Another good way how to explain you what is functional programming could be its comparison with other popular paradigms. So let's compare it with imperative and object-oriented programming. Functional programming expresses what to do via declarations and transformations. It uses composability via small steps chaining, and it prevents side effects via immutability. Whereas imperative paradigm focuses on how to do the work. It uses step-by-step control flow with loops and conditionals, and it uses mutable state updated along the way. And the third paradigm, object-oriented programming, uses behavior that happens on objects instead of functions. Data and behavior is encapsulated into objects, and it leverages sending of messages to the objects instead of calling functions. The key message I want to mention in this video is that functional programming is not a replacement for object-oriented programming. All modern developers should use them together. So you should use functional programming for processing data like transformations, filtering, or working with optionals. And you should use object-oriented programming for modeling real-world entities, organizing components, and managing a state. Now let's have a look at the core principles of functional programming, which are pure functions, immutability, function composition, first-class and high-order functions, declarative style, and recursion over loops. So let's start with the first one, which is pure functions. By definition, a pure function is a function that always produces the same output for the same input and does not cause any side effects. In our example, we have pure function called square. It will produce always the same output for the same input, and it doesn't cause any side effects. For comparison, here is a multiply and log function that basically takes input and multiply it with a multiplier that is defined outside of the function. It breaks the rule because the result can be different in case we change the multiplier. So for the same input, we will get different outputs based on the multiplier value. And also it breaks the side effect rule as it prints result to the system output. So the second mentioned, immutability, it ensures that data remain unchanged, making program behavior more predictable and easier to reason about. In our example, we have a point defined by two coordinates, x and y, and we have a method moveRight, which takes step. When we call moveRight, it creates new instance of point with the moved coordinates. This supports immutability as the original point is never adjusted, but the method creates a new instance. And in our second example, the moveRight method breaks the immutability as it modifies internal state of the point. The principle number 3 is function composition. It enables building of complex functionality by combining smaller, reusable functions, resulting in cleaner, more modular code. As we can see in our example, the same logic is written with function composition versus with loop and separate method calls on the objects. From this example, it's very clear that the function composition produces more cleaner and readable code. The principle number 4 is first class and higher order functions. First class functions are functions that can be stored in variables, passed to functions as parameters, and returned from a function. Higher order functions are functions that take other functions as parameters or return functions. In our example, for example, process is higher order function as it takes filter and transformer functions as an input parameters. Also, add suffix is higher order function as it has a return value of a function. And then we have example of first class functions where we store functions into variables, and then those variables are passed to the higher order function process. The principle number 5 is a declarative style. It focuses on what the program should accomplish rather than describing how to perform each step. In our example, we have two versions of a method that both return names of active users in uppercase. As we can see, the declarative style is readable and clean and focuses on what, whereas the imperative style requires for loop and control over what exactly should happen and how. Finally, principle number 6, recursion over loops. Recursion is often used for expressing repetition without relying on mutable state or imperative flow control. In our example, we have two versions of factorial function. The first one, written in functional paradigm that uses recursion. As we can see, the method is recursively calling itself with the condition of base. Let's have a look on why to use functional programming and what are its benefits. The benefit number 1 is predictability. Pure functions and immutability makes programs' behavior more predictable and easier to debug. Testability. Self-contained functions are easier to test and maintain in isolation. Concurrency. Stateless and immutable data enables safe and efficient parallel execution. Reliability. Declarative style and composition reduces boilerplate and makes code more expressive. Scalability. Small reusable functions lead to cleaner architecture that scales more easily. Functional programming is supported in modern languages and aligns with today's software architectures. Now, you don't have to wonder what functional programming actually means. With just a few concepts, you can start to apply it in your everyday code. Start small and you will be surprised how much cleaner your code base will become. If you found this video helpful, make sure to give it a like and subscribe if you want to keep learning. Thank you. See you in the next one.